Okay. Good morning, Belcher. I unmute you. You need to unmute yourself, then you can welcome everybody.
Hello.
Dobar dan svima.
Hello.
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 Dobri deň.
Hello, hello.
Ja bih se htio zahvaliti svim sudionicima webinara iz Hrvatske, Bosne i Hercegovine i Crne Gore na sudjelovanju u ime tvrtke Belme 97 iz Zagreba i naše partnerske tvrtke leXsolar. Zamolio bih sve sudionike webinara koji žele potvrdu o sudjelovanju na webinaru da mi se jave na mail koji ću upisati u chatu, pa evo, uglavnom da imate potvrdu koju ćemo u roku nekoliko dana isporučiti, tako da evo, to je što se mene tiče ispred Belmeta 97. Michael, you can go.
So hello and good morning from Dresden in Germany. I'm very happy and welcome you, and I'm very happy that so much participants of you coming today to our webinar. We would like to talk today about new energy in Germany and Europe, present by our head of development, Mr. Dmitry Kushnikovsky. And we would like not only give you today an overview about the technology, we would like give you also some direct view in our products with some live experiments, and we would like give you some possibilities to see what you can do with our products in your school or university activities. Some important questions. We would like record the webinar when you agree. Also when everybody of you agree with this, and then Mr. Rimac can share this record with you later. But when somebody have a problem with this, then please give a sign and we will do it.
Ok, ako neko ne želi da se snima webinar, recite samo pa nećemo snimati, ali to bi htjeli onda poslije podijeliti da možemo, da ako nije mogao sudjelovati, da može sudjelovati nakon toga. Ako neko ima problem, ne kaže slobodno. Okay.
Okay, good, great. Good. For the general organization, I don't know, everybody know of you how Microsoft Teams works. It is similar like Zoom, but some functions not the same. When you have any questions, you can raise your hand or send a chat message, maybe direct to Pericha. You can then share with us. Mr. Dimitri would like answer the question immediately, but then when he working and make presentation, of course, that is then, and maybe also make the live experiment, he have now all the job to do. It's sometimes maybe a bit difficult, but we have each time place to answer any questions, and for us it's then also a nice feedback. When you have question, it's mean you watching us very attentive. Okay, then from my side, it's all. Dimitri, the floor is yours.
Okay, thank you. All right, so yeah, Dobar dan iz Dresdena, and today on behalf of the leXsolar, I would also like to thank you for the participation, and I think we will get started. So let me just share my screen. So yeah, also a couple of organization comments. You guys in principle can also pin me, so there is like 3 dots in Microsoft Teams, yeah, so somewhere around my picture, and you will be able to see me in a full screen, which will be especially helpful while I will be demonstrating you some experiments with our products. Well, or there is in principle other option, we can do it ourselves. So if you guys also have questions, I think we will do like 3 short stops somewhere between our products, and you can always ask them, or if you also have questions during the presentation, you could just simply type them in chat, either in English or Croatian or any other language you guys speak. And then I think with the help of our hosts, we will also try to answer it somehow. All right. So I hope you guys can already see my screen. Yeah. Okay. Good. Then I think we will get started. I will also ask you. No, it's actually fine. You can also comment probably during the presentation. All right. So if you guys don't know us, we are called leXsolar, and we are a company based in Germany. And today, so I will be your host as well as Mikhail, who already took a floor. So we are a company which is founded in 2003 in Dresden as a spin-off as a technical university of Dresden. And we are specialists in education in terms of the renewable energy, in all renewable energy fields. So we have several product lines which covers in principle all of the educational levels, starting from the kindergarten and up to the first, second year of university. So and today we will be talking about 3 of our products, so with some demonstration as well, which are specifically designed for technical vocational and educational training, as well as for training in the high schools and in colleges and universities. All right. So let's get started. Here you can see in principle the short overview of the fields where we're active are, and that's that's basically everything. So starting from the solar energy, wind energy, thermal energy, you just name it, up to the different energy storage technologies like battery and accumulators or hydrogen storage, and to the bioenergy and biofuel. Okay, so today we will mostly focus on okay, so yeah, that's we already spoken of. And today we will be mostly talking about solar energy or photovoltaics, as it's a second name. Okay, so how the photovoltaic works, I think most of you already know. So it's basically what's actually a solar cell. So it's kind of a sandwich type device made of 2 types of semiconductor, which is one of the being a p-type and the second is a n-type, and mostly the electricity is generated when the solar cell is being irradiated with some light, and upon a certain frequency the electrons, so there is also an effect of electron hole transition, and yeah, so we basically just start generating some electricity. Of course, there are many more different technologies involved, and so what you can also see in this relatively short summary of most of the technologies available at this moment. So, but also please keep in mind that these are mostly a lab, different lab text, and the real-time application and especially efficiency is at this moment is a little bit different. So as you can see, there are a lot of emerging technologies involved, and currently the photovoltaics is in fact the most technologically developed field of renewable energies with a maximum theoretical efficiency, which has been quite recently developed. I think it's been January or February this year, of around 48%. However, if you're talking about the real-time application, especially about the devices that are currently being used in the public field, so we are talking about something around 18 to 22%. Okay. At this moment, there are also mostly 3 different technologies which are currently present on the market, which are a thin film or a multi- and polycrystalline silica. And the tendency is that poly and the single crystalline silica are currently occupies the most of the market share, being around 90 to 95%. Because of its a relatively cheap technology, also a quality control is good enough, so we can in principle produce a defect-free cells of any size and well, basically any shape. Okay, so it's already known that photovoltaics is also currently being used pretty much well everywhere, starting from the pocket-sized calculators and up to the International Space Station, and as well as residential households, and pretty much everywhere. Okay, so now let's talk a short about the photovoltaic in Europe. And Europe currently has around a quarter of the total share of the installed capacity of photovoltaic devices in the world. So when we are talking about the installed capacity, it means that it's a sort of total capacity which has been installed at this moment. So it's not the amount of energy that we're generating, for example, in a year or so. No, we also need to to get the final power output or energy output, we also need to multiply it for the number of hours or any other units that the photovoltaic cells also have been into work. The tendency right now, especially in Europe, is also a little bit switching towards the direction of the larger power plants. Because if you talk about a past, or well, not really the past, but like 5 years ago or so, most of the power plants were small or medium-sized, and especially, even the small photovoltaic setups which were installed somewhere on the residential households, like for example on the roof or somewhere or on the industrial buildings. So right now the tendency is also switching towards larger power plants. And okay, so yeah, I was talking about this 138 gigawatt of photovoltaic capacity. So just to give you a rough estimation, it's around 30 one of the largest coal power plants could have been replaced by the photovoltaic setups right now. Okay, so let's go to some of the examples, and this is one of the latest examples from Germany. Wilhelmsdorf power plant, which is located just, I think, 25 kilometers from Berlin. And at this moment, it's the largest solar power plant in Germany. It just recently has been commissioned, and with an installed capacity of 187 megawatt, or which results in the annual electricity production of 180 gigawatt per hour, which is in principle enough to supply around 300,000 households in Brandenburg. Okay, so we will move to our product in this field, which we call leXsolar PV Professional. So it's an experimental system which is specifically designed for electrical engineering and renewable energies engineer, and it's a photovoltaic kit for the technical training, which teaches the students the basics of photovoltaics, as well as gives them some understanding on the basic components of photovoltaic setups. And with its help, students can also make or design a complete tabletop or table-sized photovoltaic system, so basically in a laboratory scale. Okay, they will also get some understanding about, as I already told you, about the photovoltaic basics, how the cells are working, so what kind of cells they are present, and some main components like maximum power point tracker, inverter, different types of PV systems like on-grid, off-grid, and hybrid systems, and the dimensioning of the systems. And of course, besides hardware, they will also get a complete curriculum, as we also provide with some of our experimental products, which is 4 consecutive sessions divided in 15 units, which is in principle enough to occupy them for a while. Okay, So now let's have a look on what we have in the case. I will also show you later in a couple of minutes. So we will just quickly do it. So it's some solar modules, several of them. It's several consumers. It will also be using a semiconductor diode, regular type, shunt regulator, which is in principle device that can. So it's a two-level switch, which can switch off the circuit if the voltage reaches a certain level. So meaning that it can also prevent for our batteries from being overcharged or deeply discharged. It's also a deep discharge protection, which is a single level switch which prevents our batteries from deep discharge. It's once again one more consumer. It's an AV module, which is basically a multimeter and helps us to measure simultaneously voltage and current. It's a heart of our system, which is our base unit, and can actually accommodate 4 of our modules at once. A capacitor module for energy storage, a series regulator, inverter, so a DC AC, so that we can also variably control the frequency of the output current, so from half a gigahertz up to 15 hertz. It's a maximum power point tracker, which is also some sort of the DC inverter. So yeah, DC transformer and pulse width regulator, and several of the resistor plugs. Okay, so we will also provide you with this presentation. So if you also have an interest, you can later on have a look on some of the products, because we have fitted this presentation with pretty much everything that we can, also with some video demonstration. So if you have interest, you can later on have a look. But right now I will switch my camera, and we will make some experiments. Okay, great, it works. Okay, so to give you some better understanding, this is how it looks. So it's all of our products are supplied in such an aluminum case, which is really good for transportation and storage. And here we also have most of our components that are currently available. Okay, so now once again, that's our photovoltaic experimental system. And yeah, let's have some demonstration of this. Okay. So we will do today a couple of experiments. So we will start with some basics, like some serial connection of the solar cells in series and in parallel. So as I already mentioned, we also provide several of the solar cells. So like for example this one, which is a large size in our case. And two smaller sized solar cells having a different power output and of course also voltage and current output. Okay, so we will start with some basics, and I think we will start with a serial connection. Okay. Another issue today is that we are currently in Germany, and we don't really get much sun today. Well, let's actually start showing up. That's why I will probably need to simulate our sun by using the lamp. Okay, so yeah, as you can see, it's kind of a modular system. All we need to do is just to plug in our modules, and then we will be good to go. We also need this short circuit plugs. So to complete our circuit, to close our circuit, and just one more cable. So, and to get some understanding, we will also oops. Okay, so in theory it should work. Well, it doesn't, because the light intensity right now, the sun intensity, looks like it's not enough. So let me then connect the lamp. Okay, so what did I do? All right, yeah. And as you can see, so if we irradiate it with sunlight, and our cells starts generating some electricity here, which will also cause our motor to rotate. So we can also, of course, measure the current as well as so which is around 100 milliampere right now, or we can also measure voltage at the same time, so which is 1.5 watt. So that's in principle what we also expect in case of the serial connection of the solar cell, so that the voltage will also sum up because we're connected them in series. So if we do a parallel connection, so which we can just simply do by rotating them at 90 degrees. Then we should get some other result. Okay, so as you can see, it also works. The motor, however, starts to rotates not so fast as it used to be. And if we measure our voltage, it's around 600 millivolts or 550, which is also as expected. In this case, the current sums up, but the voltage stays the same, also because we also connect them in parallel. So these are some basics which we can also perform. And right now, let's do something a little bit more complex and probably more interesting for us. And we will simulate some off-grid photovoltaic system. Off-grid in our case means that there is no connection to the electricity grid. So it's an autonomous system or an autarkic system as well. Okay, and for it I will need some modules. Okay, so yeah, we can basically do the simplest circuit possible. Yes, so we can take our solar cell. And connect it directly to the consumer. And you can see so that power output is in fact quite actually a lot, because a motor rotates really fast. However, it's also not so good if you think from the position of the end customer. Yeah? So it means that the power output can be either too large or too small. Yeah? So which can in principle damage our electrical equipment. Therefore, it's actually better if we let's actually measure the power output. So, okay. Okay, yeah, so it's like 5 volts, so basically, which is quite a lot for our purpose. Okay, so therefore it's better if we do sort of a hybrid system and we install a capacitor which will also be in use, and for even when there is no sun, we'll still be able to use our equipment. So as you can see, it's actually works right now, even without the sun, so because the energy is supplied, so electricity is supplied from our capacitor. So if we switch the lamp on, our capacitor also will start charging, which leads us, however, to the second problem. We should also charge it only until a certain point, yeah, because otherwise it can be damaged and then inevitably destroyed. So that's why we'll also need another component, which is a deep discharge protector. So it's a sort of a switch which will also be switched off, so it will also break the circuit somewhere here if the capacitor reaches a certain level. So it's not yet done now because oops, actually, yeah. Okay. I'm a little bit too fast here, so we need not the discharge protector in this case. However, we will need a series regulator customer, yeah, so which will also prevent it from overcharging. Yeah, otherwise capacitor can just simply blow off. Okay, so yeah, that's why it will protect our capacitor from being overcharged. The second problem, however, is also a deep discharge, and we also should prevent our accumulators from being deeply discharged. Otherwise, they can also break. So meaning that we will also need a deep discharge protection, which will also switch it off, which will also break the circuit to our consumer if the voltage of the capacitor drops below the certain point, which is in this case I think it's like 2.6 volts or so. Okay, good. So and okay, good. As expected, it works. Okay, so right now we have the most complete circuit. There is, however, one more device that we can use to optimize our power output from the solar cell, which is this MPP tracker, so which is sort of a DC-DC converter, which has also two different modes. It's either a manual one or an auto one, and we will be using it in complete automatic mode. So that the power output from the solar cell will be always at maximum. Okay, so now you can see, and if we measure the voltage is right now also at its maximum. So what it does, it also adjusts some, so basically it also has some resistance and it adjusts the current, that we also get the maximum voltage and the maximum current, which, and of course the multiplication of them gives us the maximum power output. Okay, so yeah. So as you can see, with the help of such system, we can basically design our own tabletop or table-sized hybrid photovoltaic system. Okay, so we'll just quickly put this away and we can continue. And if you guys have questions at this moment, you can start asking. Okay, are there any questions? And yeah, okay, so with the help of such experimental system, we can perform up to, I think, around 40 different experiments. And if you're also creative enough, you can, in principle, design your own. Okay, so let me switch the camera back.
I have a question regarding the base, the stand. Is it possible to make a bigger one, or it's only this small one? If you do more components to each other, do you know what I mean?
If I understood you correctly, I think you are talking about the so the base unit, right? Or
Yes. The base, the stand, where the components, there is possible to put 4, I think, 4 components. And do you have a bigger one?
No, we don't have a bigger one. However, we also have a system. You will see, I think, shortly, where we have, for example, 2 of them. So meaning that you can connect up to 8. And in the same time, you can always connect more and more by cables. Okay. So it's a 4 components just simply fixed, can be fixed on the base unit itself. how many components can be used in total? It's quite a lot.
Okay, great, thank you.
Okay, welcome. All right. So, and we will be also moving towards a different topic right now, which is an e-mobility. Let me just quickly find it. Oh yeah. Because one of the problems is also generating of energy. The second problem is also how can we store it. And the typical answer is also we can store it in some sort of batteries. Yeah? And one of the typical also battery application is the energy storage devices for the electrical vehicles. And currently, electrical vehicles is also quite a growing market, especially in Europe and especially in Scandinavia. If you take it into account, with for example, when the recent sales of the electrical vehicles resulted around 75%, for example, in Norway. Yeah. And especially in Europe, the plug-in or full electrical vehicles are quite popular right now. And it's expected that the current number will also grow within the years quite significantly. And at this moment, the electrical mobility market of Europe currently occupies the second place, just a little bit shy behind China. And the leaders on the European market is of course it's Norway. Yeah, so with around 500,000 of total units in use at this moment, especially if you are talking about the plug-in. So plug-in and the full electric vehicles and the hybrids as well. Which is quite a significant number, especially for Norway. So which also has the largest vehicle number per capita in Europe. Well, even when compared to Germany, was for example 8.4. And it also has one of the largest number of the charging points across Europe, and especially the tendency right now is also to unify the charging standards and to put the similar and fast and ultra fast charging stations in Europe. So yeah, here you can also see the number of electric vehicles per capita as of December 2020, with Norway standing from around 90 electric vehicles. Which is the world leader at this moment, and with Europe on average around 6 vehicles per 1,000 people. Okay, so let's have a look what we have in this field, and we have a product which is called leXsolar E-mobility Professional, which is also an experimental system for some basic training in terms of the different battery technologies. We also included with several other battery technologies and a reversible fuel cell. And what it means and which technologies we have, we will also see in a couple of minutes. And with the help of this battery training, students can also understand the correct charging and discharging protocols for battery, because also what CC or CV means, how we can utilize it, how can we also create our correct charging protocol or a battery system, how can we treat batteries to prolong their lifetime, and also what battery technology is suitable for the particular application. Therefore, we also supply the case with several battery technologies, so namely it's a nickel metal hydrate, it's a lead acid, lithium polymer, nickel zinc, lithium iron phosphate, also supercap to compare the capacitor with accumulators, and a reversible fuel cell, which can be used as both electrolyzer and a fuel cell itself. Yeah. Let's therefore shortly have a look on the components. It's once again, as usual, we also have several consumers, resistors that we will also need, a potentiometer, so a supercapacitor that I've already talked about. It's a charger module which is specifically designed to provide a suitable charging protocol for different sorts of battery technologies. And so here you can see it also can work in a constant voltage mode as well. Okay, so it's a reversible fuel cell and our batteries. Also our electrical current, so it may be not so fancy as the one that you can see on the picture. However, it does the job just fine, especially for the purpose that we need it for. Yeah, so it's a triple battery module which can accumulate up to 3 nickel metal hydride modules, and the battery adapter cable which makes every energy source or every battery suitable for the 4-point measurement, meaning that we can get correct voltage numbers and therefore also measure the internal resistance of the voltage source and of the included PTC fuse. Also our EV module that we can measure voltage and current, and a couple of and a multimeter as well. Okay. So yeah, as I already told you, we also have a couple of experiments included, and if you have interest, you can later on have a look on it. Okay, in this time I will also switch back to the second camera and we will also have a look on the case itself. All right. So, yeah, let's look what we have inside. In principle, we just discussed it. So once again, it's several of the battery modules that we have here, also a couple of consumers. And what's particularly interesting is yeah, so this reversible fuel cell, so which is able to to generate hydrogen as well as to later on use it for any applications that you need it for. We use this in this case to power up our electrical vehicle. Okay. So yeah, it's also accommodates with our professional base unit that can hold up to 4 different modules. Okay, so we will also start with some basics like connection of the serial connection of several voltage sources. So we will use a single and triple module. And we will also need a couple of resistors to do the job. Just fine. Okay. No. So yeah, students can in principle get some basic understanding on what happens if we connect several voltage sources in series or in parallel. That's also possible to do. And therefore, they can measure it. So for example, right now we have around 140 millivolt. And if we connect 3 of them right now in series, so we get this number ideally tripled. Sorry, and that's exactly what we got. All right. So we can also do a bit more complex experiments, like we can measure the internal resistance of the, for example, let's measure the internal resistance of the PTC fuse that we also have in every module installed. We will use for this purpose lithium polymer. So there is an adapter installed in every, and what we need to do is just to take our multimeter.
Το πού είναι ο Βρήτος. Δεν ζητήσα.
Okay, sorry. Sorry, how long I've been unmuted? Excuse me? Just a question, so how long I've been muted?
For 15 seconds, maybe.
Okay, I don't know. All right, anyway.
All is fine.
Okay, yeah, so that's some technological mystery we will never solve. All right, so yeah, once again, so basically with the help of such adapter, we can measure also directly the voltage of our source, and then we can also calculate it by knowing four values. So with a closed circuit and with an open circuit. Yeah. We can also investigate, for example, the temperature behavior of such battery if we take a potentiometer, which is basically just the two real states. And if we measure its resistance. So because we also have either a PTC or NTC installed, meaning that we can also see how the resistance will change. And from the changing resistance, we can also deduce its temperature. Because we can, in principle, know get some ideas from the resistance and calculate the temperature, knowing if it's an NTC or a PTC element installed. Okay, and the last but not least, we can also charge our batteries, charge them correctly. By using our charging module. And therefore also understand which charging protocols is currently used for the particular device and see the difference between different battery technologies. So all we need to do is just to select a correct device that we have in use right now, and it will start charging. And here you can see right now, so we started with a constant current mode, and right now we're also going to the constant voltage. And depending on the battery type that we chosen, we will also get a different charging protocol. So yeah, that was a short summary that we can also do with this product. And let me quickly pack it, and we will move to our last one for today. Okay. All right. So in the meantime, we will. Okay, that should be working right now. And yeah. Okay, hope you can see it back. So my screen sharing, and let's move on. We will move right now towards the smart grid. And essentially, the question arising also, what is a smart grid? It's an intelligent network that also takes into account an energy generation, energy consumption, energy demand, etc., which is particularly useful since the introduction of the new and renewable energy sources, which are also currently being integrated into the net. So yeah, this electrical network also takes it in account. Because the renewable energy sources can be also installed somewhere in remote areas or on a private households, and they also either need or do not need an integration into the net. And the second issue is that the energy supply from the renewable energy sources, it's also not constant, right? So because obviously the photovoltaic setup cannot generate energy during night. Or, for example, a windmill is also mostly productive only during night, but not during the day. Okay, so and the smart grid also takes it into account. It also can prognose the energy supply and the energy demand within the time, and can calculate it, and can also cooperate with the energy consumer and energy producer as well. Okay, so it's obvious advantage that we know our current consumption and current generation, and of course knowing that can also prevent the blackouts and things like that. There is also an organization in Europe right now, which in principle also responsible for the development of the smart grid all across Europe, and currently 34 different countries taking part in such organization. So it's called the European Network of Transmission System Operators for the electricity, and it's also responsible for the integration of the renewable energy sources to the grid, which is also quite useful for us. All right, and yeah, so long story short, we also do have a product in this field, which is called leXsolar Smart Grid, and it's designed for also for basic training and engineering, and it's a complete smart grid on the laboratory scale. With the help of the system, you can investigate different smart grid properties. You can also integrate different energy sources. You can simulate different scenarios, compare conventional grids to the smart grids, also investigate the grid stability of the distribution systems, and also integrate different energy storage technologies in it, because as we already mentioned, it's not a problem to generate the electricity. It is a problem, however, also to how to transmit it and how to store it, because we can also lose electricity during both of the processes. And it's also integration of the grid with the e-mobility and energy storage technologies. So at this moment, it's the most complete system, and we have lots and lots of modules in it. And let's have a look what we have inside. So it's above mentioned and already familiar to us solar cell module, several consumers like a light bulb, also potentiometer that we can use as a consumer, a motor module. We also provide this case with a wind turbine, which you can use to simulate the windmill. Also with a different type of rotors, which can accommodate from 3 blades, also 3 and 4 blades of different type of geometry, which is also quite useful. A diode, also capacitor, MPP tracker, so these components we already know. Base unit, AV model we also know, so the fuel cell, which is also familiar for us, and a couple of, and the battery as well. Okay, so and now let's have a look what we can actually do with the help of all of this. I will demonstrate, I think one experiment we only have time for, and then if you have questions, you can also ask them. Okay, I will switch the camera once again. And stop the screen sharing. Okay, so let's open our kit. And here you can see it's also packed with quite a lot of stuff inside. Also to answer the first question about how many modules can we actually use and how many can we fit. So this particular product, for example, is equipped with 2 of our base units. So you can, in total, connect up to 8 modules. And we can see right now that, in fact, we can connect even more. Because I'm planning to use, well, pretty much everything what we have in the case right now. So, right now we will simulate the energy behavior of the 2 different households with energy supply from both conventional and the renewable energy source. So, yeah. Okay. Also, as a reminder, we also have this wind turbine. In this case, with a complete also wind machine that we can also use for the as kind of our wind supply. Okay. I will also need 2 of our grid modules, which we also use for the simulation of the electrical grid. Meaning we can also take into account some energy losses due to the temperature. Yeah, due to the rising temperature of the energy conductor. So we will also need our power module, which is also which we will use as our energy supply, which will also be simulating our conventional power plant. Let's say it's like a coal power plant. Then we will also need to see all the smart grids or smart meters, sorry, which we'll use to see the energy consumption of our two households. And two of the households. I think we will need some more. And we will also use meter task MPP tracker. Okay, so and once again, we can even further extend this experiment later on and connect, for example, an energy storage somewhere that we can see what happens and how can we store the energy right now. Okay, so yeah, let's start building it. So the circuit is organized in such a way that we actually start from here and it will go all the way like this. Once again, this is our smart grid module, which is just basically a NTC or a PTC element. So then we have our first household, which was supplied only from the conventional power plant at this moment. So basically, you can understand it in terms that we have a conventional power plant, and we have a transformer, and we have also an electrical lines which goes from the transformer to the households. Yet another household. And the MPP tracker. Okay. So we will also need some power lamp because it seems that it's not going to be enough sun for now. And we will also simulate it during the day, meaning that we will start with a case when we have, for example, no sun or there is no wind or something like this, and the energy will only be delivered from our conventional power plant. And also connect both of the base units. So that we have a closed circuit and everything is connected. So it kind of looks like the case. Let me see. Okay. Looks like I forgot something. Now it works great. Okay, so yeah, we have a scenario right now when those households are just are being supplied from the conventional power plant. That we can also deduce from because two of the models are right now light up. So you probably can see it. And sometimes I will just change our consumer for the motor module, which will be rotating the star. Okay, so we can see it works. Yes. And let's simulate right now some behavior when the sun is, for example, just been set up. So it's around, like, let's say it's around 6 a.m. or so. We can do it more directly because we also provided the azimuthal scale. I will just, for the sake of clarity and timing, also just simply simulate it. Okay, so right now it's around 6 a.m. So the sun is up. However, it not irradiates our solar cell yet. Yeah, so because we can also deduce it. All right. So the power has a negative sign in the second household, meaning it's just delivered from the conventional power plant. Okay, so we can start rotating our solar cell, and we can also start our MPP tracker, so that some energy will also come from the solar cell. And yeah, okay, so we sort of reached the point when the energy is right now having a positive sign. And MPP tracker stopped its search, meaning that right now this household is completely supplied from the energy, which we can say is around 9 a.m. So if we further rotate our solar cell, we are simulating that the sun also optimizing its the position of the solar cell is also optimized towards the sun. Right now, we can also deduce that, in fact, the first household is also already supplied with the electricity produced only from the solar cell. And even if we switch this one off, for example, I can even completely unplug it right now. So you can see that the electricity produced just from the solar cell is enough, and we can create also a completely independent on the grid system. Moreover, we even have some leftovers of energy right now that we are not using. So we can even further extend such system by connecting, for example, okay, we can even connect our reversible fuel cell and store our electrical energy in terms of the chemical energy. Yeah, so meaning that we can even create the complete green production method of the hydrogen and use the leftovers of our energy. So we can either deliver it back to the grid, or we can use it to store the energy if it's an autonomous system, or we don't want, for example, to sell it back to the grid, because also not all of the countries at this moment have a green tariff. So yeah, we can store it and utilize later. We can store it as a chemical energy, for example, in our reversible fuel cell, or we can store it as electrical energy directly in our capacitor or in our accumulators. So yeah, this is one of the scenarios that you can also make by using this system. You can also use, instead of solar cell, I don't know, for example, a windmill, and in principle, a total of also around 30 to 40 different experiments can be performed with using a smart grid. Okay, I think that's gonna be it for now, and I will switch it off. and if you have questions, yeah, I think it's time for them.
Dimitri, I put a question in a chat. Maybe I can answer from your point of view.
Okay, well, just a moment. Let me quickly get the camera back.
Yeah, and for everybody, we coming now, as that is now the end in the presentation of the live experiments, how we make in the invitation of this training day today. We're talking only about 3 topics. We have around 9. Then in the virtual or in the presentations themselves, what we would like share with you. And now we would like open for everybody to ask your questions, what you have. Maybe not only for the products what we present today, maybe when you have questions also for the other products. It's now for you the possibility to ask. Just now Dimitri asked the development manager of us, and he give you for each question and answer from the point of the developer, not only from the point of the sales people. And maybe first question of me was, can I compare or can we compare?
I've seen it.
Yeah, okay.
Well, we can compare it, in fact, yeah. So, and of course, every single product also, I mean, both products can exist, and both can have their advantages and disadvantages. And our advantage is in this case that we also have, our system is a mobile, it's a table size, and you can use it pretty much everywhere, because we also have all of the ancillary components. Inside the case, we also supply it with manuals, both student and teacher manual, and also curriculum for complete curriculum for some of the products as well.
Bertha, maybe you have a question, what you can answer from your side, of the partner side, from the partner side.
I don't have some special question, but I know something about your product, but I can speak at Croatian.
Sure,
Ako
sure.
neko ima nekakvo pitanje, bilo šta, LEXsolar ćemo prezentirati sljedeći tjedan na WorldSkillsu na Velesajmu, tako da imat ćete prilike, ko bude došao na Velesajm imat će prilike uživo poigrati se, provjeriti kako to radi, tako da imamo 2 demonstracijska seta ćemo imati tamo izložena, tako da evo, za bilo kakva dodatna pitanja možete i mene konzultirati i ako bilo šta treba slobodno. Sad ću napisati u chat room svoj mail, pa bi vas zamolio ko treba potvrdu o sudjelovanju da mi pošalje samo naziv ustanove i vaše ime i prezime, normalno da možemo napraviti to što treba. Mihael, Dmitri, I tell to all professors that we will present your product next week at WorldSkills in Zagreb. It will be few thousand students and some professors and who want to see that set. They can see in live. Okay. And if somebody have some question, they can ask me, and I will ask you if I don't know. And okay.
Great. Then we are very well in time. Thank you, Dimitri. You have most of the work today. That was a very nice presentation, and all was working well. Of course, we can show you only one experiment in this short time. You can be sure you have a lot of things to do when you make the experience, and also with your students. But I'm also sure it's make a lot of fun to work with these products, because product also gives possibilities and reliability experiment results for the student. That means not so much surprises when you work with the products. What is each time good when you prepare your lessons for the students. Yeah, and then I think I'm very happy. I will tell you that that was one of the best meetings in Europe what we have already, with more than 54 participants. Okay, when we reduce for the leXsolar people and the partner people, it is also around 50 participants, and that's make us also very happy, and we are very happy about this response and interest from your side. Of course, also thanks to Mr. Pericha that he organized very well and contact you very actively that you will be join this meeting today. And yeah, when from your side no more questions, we are happy to see you soon and welcome you soon as a customer of leXsolar.
And probably from my side, so if you also have an interest, we can later on supply you with this presentation, and as you can see, we have many more to go. So it contains most of the information on our products and also some theoretical information as well. So yeah, if you want, we can also later on send you a link to it.
Okay, we have some question to answer.
We got a question from Mr. Alexander. Can we combine two individual experiments in your complete example? Combine solar panel with battery.
I see. Sorry, there is no need to read.
Okay.
Yes, sure. I mean, we can combine it. Even right now, you probably saw that I wasn't actually strict enough, and I wasn't really strictly following our experimental guide. Yeah, so and our experiments, you can actually modify some of the experiments that were not mentioned, which we have, however, also developed. Use quite a lot of the components, so you can also generate, like for example, also charge a battery by using the solar cell, or use the solar cell for the completely green generation of the hydrogen. So you can combine the experiments well, basically as you like, and that's actually a beauty also of our experimental system, so that all of the components can be used interchangeably and also within several of different experimental systems and different products. So the answer is yes, you have quite a flexibility.
Okay, welcome. So maybe that's it. Maybe Pericha, you give some final words to finish the lecture and the lesson.
Je, ok, Mihael. Ja bih se još jednom htio zahvaliti svim sudionicima webinara. Ja se nadam da je bilo ok, da je bilo dobro. Prvi put nam je to bilo sa tvrtkom leXsolar, tako da evo, ukoliko bude zanimljivo, organizirat ćemo još koji, tako da evo, to je to. U slučaju, rekao sam da ćemo prezentirati na WorldSkillsu, ali nije problem, ja kako dosta po školama obilazim, nije problem ni prezentirati u školi bilo koje i setove i to, i čak ostaviti u školi da se profesori ili učenici igraju neko vrijeme sa tim da malo provjere i tako. Evo, uglavnom to je to. Hvala vam još jedanput i pozdrav. From me it's enough, Michael. I think so.
Alles klar. Dann thanks a lot and bye-bye from Germany, and see you soon somewhere on the next exhibition in face-to-face meetings. Okay.
Thank you.
Thank you very much. Hvala.